lesson, we're going to be talking about how to make a box plot. A box plot is a visual representation of the 5-number summary. If you don't know how to find the 5-number summary, check out our previous video, and that'll go through the steps of how to calculate those numbers. A box plot, it can also be referred to as a box and whisker plot, and you will definitely see why it has that name in a second. A box plot, however, can shows the data broken into 4 pieces that each contain 25% of the data points. Okay, so let's look at an example and go about creating a box plot out of it. So here we have a set of data, and so the first step that we're going to have to do is to find the 5-number summary. Okay, so the 5-number summary first requires us to put all the numbers in order from least to greatest. So we'll start here, 75, and we'll continue to list the numbers in order from least to greatest all the way up through our 2 values of 100. So once we have the numbers in order from least to greatest, we can quickly just find the lowest score, which is a 75. That's our lower extreme. And our upper extreme is 100. The median, let's work our way in from each end. So 75 and 100. So our median is 92. Then we're going to go ahead and find the lower quartile. So don't include 92, just look at your lower set of data. I'm going to change into purple here. So in our lower set of data, we'll make cross-offs as well, 75, 90, 77, 89. So we're going to be looking right in between 82 and 85. So if you added those and divided by 2, you would get 83.5. Okay, we're going to look at our upper half of the data, 9,300. So here we'd be right between 95 and 95. That's much easier, so that is 95. So we've just found the 5-number summary. So now what we're going to do is we're going to graph this. So we're going to make a consistent number line. And we really only have to go from Q0 to Q4. So our lowest point in the data was 75. And our highest point in the data is 100. Okay, so seeing that, I'm going to go ahead and try to count by 5s here. So 80, 85, 90, 95. So in step 2, we're going to make a vertical line above Q1, Q2, and Q3. So what do I mean by that? So Q1 is going to be 83.5. So I'm going to add some little marks. So 81, 82, 83, 84. So 83.5 would be somewhere in between these two lines. So I'm going to make a vertical line floating up there in space. That's our Q1 score. Q2 is our median, and that's 92. So we have 91, 2, 3, 4. So 92, I'm going to make it just the same height and level with the first vertical line I made. And then the upper quartile, Q3, is at 95. Okay. Step 3 is going to be to go ahead and form 2 boxes from your vertical lines. How do we do that? We go ahead and connect them. And we've got 2 boxes. Notice they're not the same size. They might be at times, but often you will see your boxes are different sizes. From there, we want to make a dot above the Q0 and the Q4. So sometimes you'll see them made as lines, but I think it's more typical to see them as dots. So Q0 was way down at 75. We're going to kind of make it level with the middle of the box there. And then Q4 is up here at 100. So we made dots right there. Step 5 is to draw a line from each dot to the box. Just like that. And so these are often referred to as the whiskers. So you can almost see like, looks like some little cat here with some whiskers or something. Please don't draw the smiley face. I couldn't help myself. All right, so we have created a box plot. So what are some strengths of a box plot? One strength is that you can quickly see the 5-number summary. Another great strength is it shows the middle of the data. And it is also good for large data sets. What are some weaknesses? We've talked about this in other representations. We cannot see individual data values. So why is that a problem? It prevents us from calculating the mean directly from a box plot. Okay, so you might be still wondering, why would we want to make this representation? Yeah, we can see the 5-number summary, but if we had to make the 5-number summary to create this plot, why wouldn't we just list those numbers? Well, let's explore more of the power by reading a box plot. So here's an already created box plot, and as I said right away, if we have this graph, we can answer the questions quickly like, what is the median? Well, it's this middle line of the box, so that's 64. What is the range of the data set? Oh, that's an interesting question. We haven't addressed that yet. So we can see that the data goes all the way down to 50 here and up to 76. So if we subtract 76 minus 50, we get a range of 26. So we can tell that quickly from our box plot. Now, it says, what percent of the days in May were there more than 70 people at PGH Fitness? So this is a graph of the number of people at PGH Fitness on different days of the month in May. So if we look, 70 is an important number. So let's go to 70 on our box plot. So 70 is the upper quartile number. So it says, what percent of the days in May were there more than 70 people at PGH Fitness? Well, remember that we said our data is being broken up into quarters, into regions of 25% of the data values. So that means that from the lowest point to the beginning of the box, that's 25% of the data. This first box also has 25% of the data. The next box is 25% of the data, and the upper whisker is 25% of the data. So from the 70 all the way to the top, that's 25%. So that's helpful to see. We can see that there were more than 75 people at PGH Fitness only on 25% of the days. Okay, it says on 75% of the days in May, PGH Fitness had at least. Okay, so we're trying to figure out, okay, 75% of the days, how many were, what was the minimum amount? So we can start thinking about adding up these boxes together. So 75%, we're talking about these three regions here. So on 75% of the days, there was at least 56 visitors. So if a gym is, planning, for how much equipment it needs, and it knows that on 75% of the days there's at least 56 visitors, it should really be prepared for at least that many people most of the time. So it would need equipment for at least that many, if not more. Another important thing that the box plot can show us is the middle 50%. So you want to often think about where what's a typical day like. So the middle 50% is kind of give you like a typical day. So the middle 50% would be basically what's in the two boxes. So that's going from 56 up to 70. So this kind of shows where the average days are. So on an average day, that's how much the gym should expect in terms of visitors. Interesting question, were there more days in May with 56 to 64 visitors, or were there more with 64 to 70? So this is a question that throws people off a lot because they look at 56 to 64 and they're like, okay, well, that's 8 away. and they can look up here at the box, and they see that the lower box here is bigger than this next box. The next box is only a span of 6. This box was a span of 8. So people are inclined to say, well, look, this box is bigger, so there's more days with 56 to 64 visitors. But actually, they are the same. Both boxes are 25% of the data. So why is the lower box bigger than the upper box? It just says that there was a bigger range of that 25% of the data points. It's still 25% of the data points that happened in that region. So the two boxes have the same number of data points, just like the two whiskers. These whiskers look, similar in size, but we could have imagined a box plot where one whisker was much larger than another. So this kind of illustrates a little bit more about why a box plot is a useful representation of data. It can show us a lot about the data from a quick glance. Thanks so much for watching, and hope to see you again next time.